Today we're talking about CCM8, Unit 4, Lesson 4, Dividing Numbers in Scientific Notation. Some things to remember. When dividing numbers in scientific notation, use the property of dividing powers with the same base. Use those exponent rules that you learned. After you divide the numbers in scientific notation, make sure your answer is in scientific notation. This is what you do. If you need to move the decimal one place to the left, then you add 1 to the exponent. If you move the decimal one place to the right, subtract 1 from the exponent. As always, if a number has no exponent written, it's understood that it has an exponent of 1. For example, if the number is 10, then that's really 10 to the first power. Now we've got some problems. So here's what our problems look like. We've got 3.5 times 10 to the 7th divided by 2.705 times 10 to the 8th. And what I've done is I've showed you, we're going to divide the rational numbers first. So we're going to divide these two numbers. When we divide these two numbers, this is what we get. I rounded to the nearest hundredth. And then we divide our powers. When you divide your powers, you're subtracting the exponents. So this is actually 7 take away 1. 7 take away 8. 7 take away 8 is -1. So that's how I got our final answer. Double check to make sure it's in scientific notation, and it is. So why don't you go ahead and try this one here. On your paper, just pause the video and see if you can model just exactly what we just did. Did you get 5 times 10 to the 7th power? Good. Down here, we're going to do the same thing. 2.7 divided by 9 is 0.3. And then we're going to focus on our powers. -8 take away -4. Okay, this is going back to your integer rules of adding and subtracting. We're going to change that subtraction to addition. So we add the opposite. So -8 plus +4 is actually going to be -4. So times 10 to the -4th power is what I've got so far. Take a look at what we've got here. This leading number is does not meet our requirements for scientific notation, so I'm going to actually have to change this number. I'm going to move this decimal one place to the right, so that means I'm going to have to subtract 1 from my exponent here. So all in all, my final answer is going to be 3 times 10 to the -5th. That one was a little tricky. Number 4 down here, again, we just divide those numbers using our calculator and we get 1.5. And then we've got to divide these powers. Like in Vic number 3, before on the previous slide, it said any number that does not have an exponent, it's understood that their exponent is 1. So I have -4, and I'm going to take away 1. That's going to be -5. And there we go. We've got all of our answers here. Does your paper match ours? Hope so. The last problem we have today is a word problem. A lot of times you'll have to kind of decode the word problem, especially with scientific notation. So let's read it. In 2000, there were 97.4 million households with telephones. The people in these households made 544 billion local calls. What was the average number of local calls placed per household? So what we need to do is we need to take those numbers, billion and million, and let's translate those into a number that's in scientific notation. So 544 billion looks like this, and using what we know about scientific notation, we just move the decimal over and then add a power to it. Same with 97.4 million. Using what we know, we take this number and change it into scientific notation. Now it says, what was the average number of local calls placed? So we're going to put calls placed in the numerator per household. So we're going to put household members in the denominator. Now that I've got it set up, or that you've got it set up, why don't you go ahead and solve using what we learned today in the video. Okay, so when we divide our numbers that are in scientific notation, this is what we get, but that's not okay because 0.559 does not meet our criteria. This number has to be in between 1 and 10. It can be 1, but it cannot be 10. I'm going to move the decimal over one place to the right. So my new number is 5.59. And when I do that, I actually have to subtract an exponent. So it's going to be 5.59 times 10 to the third, and that's the average number of local calls placed.